So in this session, we will continue with the advanced concept of Python, which
Mhm.
is oops, sorry. Okay. In the last session, we discussed about inheritance, polymorphism, classes and objects, abstraction, encapsulation, private methods, public methods, and private variables, public variables, and some other like static method and so on. Okay. In this session, we will discuss about the decorators, generators, iterators, and coroutines. These four concepts, and then we will create a project, which is a library management system with the help of OOPS, so that we can practice it. Okay, this is the plan of today. So first, what is decorators? Decorators are mainly for decorating your function. Now, what is decorating here? So first, I will create a program, then I will give then I will explain it. Okay. So let's say here we have a function. Okay, just a simple function, not a class. Okay, let's say we have this function which is my decorator. Here we will create another function which is a wrapper function. Okay, inside wrapper function, let's say I'm printing something. Let's say I am printing stubs. And then let's say I'm calling another function which is function. And that function is a parameter or we can say argument of this function. And then here we can print this line again. And then we can return the wrapper. Okay, this is my simple function. Now let's say I'm creating another function. Let's say hello. This is my function here. And here I'm printing hello. Then we have this function display. And here let's say I'm printing hello world. Okay, now I'm creating a object for my function. Let's say I'm storing my function in a variable A. And here I'm storing my function decorator. Okay, like I'm calling my function. And when I'm calling my function, it is asking for a parameter. Because here there is one parameter, we have to provide an argument. So as an argument, I'm providing a hello as a argument here. Means I'm providing function as an argument. And then I'm calling A here. Okay. And here I'm creating another function with the help of B. And here I'm again calling my function, my decorator. And in this argument, I'm providing display as a argument. And then I'm calling my B. Okay, so first I will run it, then I will show you. See, what is happening here? We are actually decorating. Like, what is decorating here? We are adding extra piece of code in the actual function. What is the actual function here? Hello. Hello is my actual function, like here. And now you can notice before hello, I have added a line here, this line. This is our decorator here.
Mhm.
Just a second. Okay, I have this function. So what is my main function? My main function is hello here. And I am actually editing my function. Okay, like I'm adding this line before my hello function, like hello character, and after my hello word. Same as I am like adding or decorating the hello world before by adding this line before the function and after the function. That is like decorating. So this is without decorator. Here we are not using any concept named decorator. Why? See, this is a simple function. We are not using any classes, not using any kind of constructor here. See, we have this function myDecorator. First, we have two functions, very simple functions, hello and display. Now, this hello function print hello, and this display function print hello world. These are my simple functions. Now, let's say I have to add these two lines before my hello. Like I wanted to decorate the hello function. So what I did, I just create another function, myDecorator. Inside my decorator, it will take a parameter. What is a parameter here? Function. This is my parameter. Okay. Now, and inside my function, I'm calling another function, which is ref wrapper. Now, this wrapper contains two lines. Okay, to print. First, this line. Okay, and this wrapper, this particular print. Okay, and then we have this second line number 4, which we have this function. Now, I'm calling a function here. I have not created a function named variable. See, we don't have any function named this particular function. We have hello function, we have display function, but we don't have any function named this particular thing. Function is a parameter here, not actually a function, but I'm still calling here. And then after this one, I am again printing this line, and then I return the wrapper. So how the code will run? First, Python sees this line number 1. So it is a function. So Python will move to line number 8. Again, it is a function. And then Python move in line number 11. Because these are function defined, function definition. We have to call them, then only we can run it. So Python move line number 14. In the line number 14, Python says, we are calling a function, myDecorator. This is my function. Okay. And this function takes one parameter here. And what I'm providing for the parameter, we have to provide an argument. So what is my argument here? My argument is hello here. This hello, which means myDecorator takes a argument which is itself is a function. And what is the purpose of this function? Print hello. Okay, and then I'm calling my function. Okay, which is I just store my function inside a variable, and then I'm calling a variable. Okay, so this line, this A will move to line number 1. Why? Line number 1 is myDecorator. Inside myDecorator, we are providing a function here. What is the function here? This function, hello. Because you can see we are providing this hello as an argument. So Python will move to line number 8. So first Python will see function. Python says, okay, it is taking an argument as a function also. And then we have this wrapper function. Python will move in line number 2. This is a wrapper function. Okay, which will return wrapper only. What is wrapper? Wrapper is this function, this function. Inside this function, we have 3 lines. First line is this print here, okay, which we are printing. Second line is calling a function. Now, what function we are calling? We are calling this function, this function. Okay, you can see function. And this function is calling which function? This function. Why? Because I am providing hello as an argument for this particular parameter. Okay, then we have this function here, and then again we have this print function, and then we are returning the wrapper here. Okay, so when I run this function, see, you can see we have this hello. Okay, before hello we have this line, which is this line. Okay, first this line printed, then we are calling the function here. And what is function here? Actually, this function. Because inside the myDecorator, we are calling hello here. And hello is the argument of this function parameter. And we are calling this function parameter here. So inside function, actually, we are actually calling the hello function. And this hello function. And this hello function print hello here. So first we call hello. And then we are printing again. And then we are printing again. So that is why you can see print here. Okay. Same as again we are creating a object here, a kind of object. You can think of a variable here. Just inside variable again we have this function, and as a decorator, sorry, as a argument we are providing display. What is display? Display is another function. So first this line will run, which is a like asterisk here, and then function. Now inside this function we have another function which is display in the second run. So we are calling the line of display, which is hello world. This line, hello world. And then again, we have this particular line. So again, I'm explaining how the code is flowing. First, Python will see this line. Okay, line number 1. Python will ignore this line because this is all function definition. And function definition is useless until you call them. Okay, so Python move in line number 8. Again, it is a function without calling. Python will ignore it and move to line number 11. Again, it is a function definition. Python will again ignore it. So Python will move to line number 14, where actually the function calling is happening. Here you can see we have this A here. A is a variable and my decorator, we are calling the function now. Okay, I'm calling my function and this function takes a parameter function, func. And here we are providing the argument because if we don't provide an argument here, it will throw the error. So what I'm providing a function as argument. And this is the hello function, this one. So Python sees this line first, line number 14. Then Python will see, okay, there's a variable which is calling the function, my function, and calling actually two functions, my decorator and hello. So for now, we are storing this inside A and then we are calling A, which is we're calling the function my decorator. And now when I call the A function here, this will move to line number first. Okay, line number this. In this line number, Python sees, okay, there's a function known as my decorator, and this function takes a function as a parameter. So for now, we are not calling this function. We are not calling this function because hello is a function itself. So we have to call the hello again. Okay, so what I did, I again create a function inside one another function. Python will move to line number second. Python will print this line because it is a simple print statement. Then Python sees line number 4. Now, what is line number 4? A function here. We are calling a function. And what is inside this function? This function is not an actual function. This function takes this hello as an argument, which means you can think of right now function is equal to hello function. Why? Because this function is a parameter, hello is an argument here like this. You can see. And here we are printing hello because now we are calling. So Python will print hello. And then we will print this statement, Python's print statement. And then we are returning the wrapper. What is wrapper here? We are just calling everything here. Like we are printing everything here. So that is why when I print this one, you will notice a kind of declaration before hello, after hello, like this one. And then we are again creating again calling my function. But here I'm using a different argument here. Previously, I was using hello. Now I am using display. So this will run hello world. So if I run this one, you will notice again a hello world. And before hello world, you will see this line and this line. So we are actually decorating the function, like adding extra piece of code before before your code and after your. That is known as decorator concept. Here we are not using any decorator. Here I'm just showing you what decorator looks like. This is a manual approach. I will show you how we can do the same thing with the help of an actual decorator. Is it clear?
Yes, teacher. Good.
Okay. So here, this is a manual approach, which is I'm showing a decorator concept. So I'm just writing here a manual concept of decorator. Now, how we can use a decorator? So I will use the same example. And here, decorate. So let's say I create another like function, same function, my underscore decorate. This will take again function as a parameter. Okay. Then here I'm creating a wrapper here again. And here we are printing all the strip. Then we are calling the function, this function, and then we are printing the line again. And then we are returning the. Okay, this is our function. This function in the our function, they are same only. There's no difference. So what we will do, now I will create a def here. Hello. Another function. This will take print and print hello. Again, I will create another function, def display which will print something else. Hello. Now everything is same as before. There's no change here. So what is change here? I will now use this function, my decorator, on top of hello and on top of display. So what I will do, I will use a at the rate here and then my decorator. Same as I will use at the rate here, my decorator. Okay. Now what I can do, I can simply call my function directly. Okay. So I can use here hello. I'm calling directly. So if I call hello, you will notice the same output. Hello, and this
Mhm.
line before and line after. It is the previous output here. With this hello here, and then with this line here again and here again. So now you can see the difference if I call display as well. Now we are actually calling the function directly. Previously, we were calling my decorator first, and inside my decorator, I am providing a hello as an argument. And then I'm saving this inside a variable, and then I'm running it. It is a very large process, and it is a very slow process. So the best approach is I'm using my hello, like I created my function, and inside my function, okay, like this is my decorator which need to be added before function and after function. Okay, like this line, print before the actual function and after the actual function. So I just use a def hello, and before def hello, I just use my decorator as top of it. So what the Python will do? Python first will see line number 1, line number 23, which Python will ignore, line number 32, which Python will ignore, and line number 36, which Python will ignore. Okay, now Python will first see line number 39 when we are actually calling the function. So when I call the function hello, Python will move to line number 32. Okay, and sorry, when I call hello, Python will move to line number 31. Here Python will see, okay, this particular function is using a decorator, like another function. So Python will move to line number, this one, my tag. Here Python will see this function and run this line. Then Python will run function C, which is this function. And then Python will run this line. So we are doing this the same process with the help of a decorator. Just by putting at the rate my decorator before the function.
Mhm.
So we are telling Python that before this function, we are using this function. So include this particular function inside this function. Same as I can create any other function, let's say def, let's say morning, my function name. Here I can again print good morning. Okay,
Mhm.
if I run this good morning, like if I call this morning here, you will see nothing here because I'm not using a decorator, just a good morning message. But if I
Mm.
use a decorator on top of this also, my tag, then you will see again some decorations. Okay, this
Mhm.
one before good morning and this one after good morning. So this
Mhm.
is like a decorator concept. We are actually decorating. Decorating means we are actually adding a extra piece of code after and before the actual function. That is known
Mhm.
as decorate. Is it clear, the concept?
Yeah, very clear, teacher. Thank you for the second, second way how to get the same output.
So this my deck are the decorators.
Mhm.
So now then we can move to the next topic, which is generators.
Generate.
Okay, so let's see. So these are decorators. A decorator in Python is a function that receives another function as input and adds some extra functionality or decoration to it and returns it. That is called decorator. This can
Mhm.
only happen because Python functions are first class citizens. What are first class citizens? First class citizens are the Python functions which can be modified, which can be added, which can be deleted, or which can be created. So that are known as first class citizens. So that is why we can add functions before and after. We can add decorators before and after the functions.
Mhm.
Okay. So there are two types of decorators available in Python. First, decorators are which is pre-built. For example, we have used this static method. We have used class method, extract method, property. These are built-in functions. And second, we can create our own decorators. These are our own decorators, my deck. We have also used in the previous classes static method and extract method. So those are built-in methods. Okay.
Mm-hmm.
Then we have this generators here. Now, what are generators? See, before generator, I just wanted to explain one more concept. Concept of a for loop. Like how for loop works. See, let's say when we are running a piece of code for I in range 1 to 10, and then we are printing the I. So what is happening here when I am running a for loop? See, here I just print 1 to 9, like numbers here, 1 to 9. So what is happening when we are running a for loop? See, when you run a for loop, let's say this is your memory. This is your system memory RAM. So when you run a for loop for I in range 1 to 10, the Python will first store all the 10 numbers in your memory. All the 10 numbers. Okay, and then print all together. Like first Python will store 1, 2, 3, up to 9 in the memory all together, and then run at one go, like 1, 2, 3, and so on. So what is happening here in the for loop? When your Python will run, the Python is running all, like Python is storing all the 9 numbers. It can be 9 number, it can be 1,000 numbers if we are running loop for 1,000 times. So Python will first store your 1,000 numbers in your memory all together. So this will take the space of a large space of your memory and then run all these numbers all together, especially like 1, 2, 3 in the sequence. So that is the very large disadvantage of using for loop. For loop we are running. For loop is like it is saying that first I will store all the output in the memory, then I will run all together. Let's say there are like millions of numbers. There are like millions of numbers. And let's say your RAM is 4 GB RAM or 8 GB RAM. Let's say you are storing a very large number, very large number. So what you will do? Python will first store all these large number in the memory. So this will take all the space in your memory, your RAM memory. And if you're very small size of memory, then you may not able to run this program. Python will freeze because there's no space left to store the extra numbers. Let's say your memory, for example, can store 100 numbers. Okay, this is not possible, but let's take an example. Let's say my memory can just take up 100 numbers at a time. But now I'm providing this much of numbers, a very large sum of number. So my Python will store this amount of number, like I don't know, millions and trillions of number all together in the memory. But my memory can only store 100 numbers. So this program will never run and my Python will freeze. Okay, like my memory will fill up and my system will hang. So that is a flaw of using for loop. For loop will store all your numbers when whatever you are running, okay, in a memory, then run it all together. So for this function, okay, for overcoming this problem, we have generators. That is the solution, that is generators. What generator will do? Generator will run function one by one. For example, let's say we are running, let me give an example. Let's say we have a simple generator function here. Depth simple generator. So here I will use a particular function which is yield. Yield 1, yield 2, and yield 3. Okay, then I'm creating a variable x and storing my simple generator function. And then see what is happening here is I will print here. What I will print? X dot underscore underscore nest underscore underscore. What is nest? Nest is a magic method. Okay, what are magic methods? The methods which are starting with the underscore underscore and ending with the underscore underscore. These are magic methods. So what is the purpose of generator? See, the for loop is for loop store all your memory, all your numbers first in the memory, then print it. Like all numbers in the memory and then print it. What generator will do? Generator will store one number at a time. Let's say we have this one number. Sorry, we have this one number. So the generator will store this first number in a memory and then print it. Then it will store second number in the memory and then print it. And then it will store third number in the memory and then print it. And what the for loop is doing? For loop is storing all the 1 to 9 numbers here in the memory and then print it all together. Okay, but what generator is doing? Generator is just like first storing number one by one and then printing it, and then storing another number and then printing it, third number and then printing it. The main difference is the generator is not storing all your number in a memory altogether, but for loop is storing all your number in a memory together and then running it. So this is generator. Now here, let's see the definition first of the generator. See, a generator function is defined like a normal function only, but whenever it needs to generate a value, it does so with a yield keyword. Yield keyword is a keyword by which you can print something. Okay, without yield, you cannot, rather than return. So we use yield rather than return. In the simple function, we use return here. Okay, like return here. But in the generator, we use yield here. So whenever you see yield keyword in a function, so that is a generator, not a simple function. When you see return keyword in a function, that is a function. But when you see yield keyword inside any function, then it is a generator here. Okay, that is a sign. So what is this generator? If the body of a def, what is body of a def? This part. This is a body of the def. Okay. If the body of a def contains yield, the function automatically becomes a generator function. So when a function contains yield, this function automatically becomes a generator. Okay. Now a generator function that yields 1 for first time, second time, and third time. For example, you can see here, if I run this one, you will see 1 only, just 1. Why? Because we are calling 1 time the nest here. So how we can print 1 to 3? We can print 1 to 3 by using nest. What is nest? We will discuss later for now. But we are using nest here. If I print another nest, x dot underscore underscore nest. See, I am now using nest again. Now this will print, first nest will print 1, second nest will print second. Now you can see we are not printing all the numbers all together. 1, 2, 3, 4, 5. We are not printing. We are printing one by one. Now it will print second here. Then I can use another nest for the third number. So this will return 3. Okay, this will return 1, 2, 3. Because we have 3 numbers in the function. If I return 4, this will give me the error. Why? Because we have only 3 numbers. And we are printing another nest here. So this will throw the error here. See, stop iteration error. Because we have 3 numbers. And now we are printing another time, 4 time. So this will give me error here. Okay. Now you can see like what is happening here. Like what is happening. See, we have generator. Generator object. Generator function is written a generator object. Generator objects are used either by calling the nest method or on the generator object, or using the generator object in the for loop. For example, we can use in the for loop as well. For example, let me give it a simple example. See, for example, we have a function def gen. Okay, this will take n numbers. Okay, n number of numbers. Then here I'm using for I in range, and we wanted to go to range n. Okay, and then this will yield 1, which is I. This is my function. Inside this function, I have a for loop. Okay, now I am providing. Now I am. Yeah, now here I am creating a object here and in J, calling a function. Here it is asking a argument, a parameter. So to provide an argument. Let's say I just want my loop to run 5 times. Okay, 5 times. Now you will see nothing will happen here for now. Because we have to call the function. So how we can call it? We can use G. You're calling it. So once I call it, again you can see this is not callable actually. So what we can do? We have to print the numbers. How many numbers? 5 numbers. Because n is 5. 5 number of numbers. From 0 to 4. 5 numbers. So I have to call the function. How we can call? We have to use this statement, print g dot nest. And what is nest? Nest will move inside this one and print the first number in the iteration, which is 0. So if I run this one, you will notice a 0 here, 0. Then I have to run nest again. Okay, this will return 1 here, 1. You can notice 0 and 1. And then I have to run this function few times. 3, this is for 2, 3, and this is for 4. So we are running 5 numbers, 0 to 4, and then you can notice 0 to 4.
Mm-hmm.
So now you can see the mechanism of running this function versus the loop. The loop is running all together. Okay, loop is storing a number in the memory and then running all together, storing all the numbers. But this generator is first storing one number in the memory and then printing it, then storing second number in the memory, then printing it, third number in the memory, and then printing it, fourth number and fifth number. So in this way, we cannot worry about the memory here because we are storing one number at a time in my memory. So if my memory storage is less, so I don't need to worry because by using generator, I'm just storing one number at a time. So this is a very wonderful uh, concept here in the Python. If you have
Mm-hmm.
very small memory and you wanted to run a very large number, you wanted to use a very large number, then you can use generators. So this will store one memory at a time. Sorry, one number at a time in a memory and then run it. Is it clear the concept?
Yes, teacher. Thank you. Thank you.
One more thing, in the function, if we create a normal function, like a normal function, let's say for I in range, and here we can use return here I. So what is the difference here? In the normal function, we use return. In the generator function, we use yield. Yield is working as return only. But what is return will do? Return will first store all your data in a memory and then run it, while yield will run one by one. That's why when you see yield in a function, okay, yield in a function, we can say inside a function means that function is a generator. Spelling and when you see return inside a function, then that is a simple function. So in place of return, actually we are using yield here. Yield will first run all the number one by. That is a example with the following. Okay. So then we have three concepts which are very important again, which is uh, see before that I just wanted to give another example. See, for example, this is a for loop. Okay. Now let's say I have a let's take another example. Let's say I have a string here. Okay, like numbers here. Let's say 1, 2, 3, 4, 5, 6. These are numbers. Now let's say I just wanted to run this number one by one. Like first 1, then 2, then 3, then 4, then 5, and then 6. Line by line. So how I can do it? How I can do it? So if I use for I in h, and if I print I, then this will run numbers one by one. Okay, like 1, 2, 3, 4, and 5, 6. Okay, now you can see there's an error here because int object. These numbers are integers. Okay, these numbers are integers. These are not iterable. Like we cannot iterate on these numbers. So I have to convert these number in a string.
Mm-hmm.
Now we can iterate 1, 2, 3, 4, 5, 6. So now Python is again storing all these number in a single memory, and then running it. So how we can use a generator here? See, if first I remove this number from like these are numbers, let's say. Now what I can do, I can create another object which is iter. Okay, IEL, let's say. And here I'm using first I'm converting my number into string. Okay, I'm converting my number into string. And then I'm using a iterator object here on top of it, which is iter here. Okay, iter here. iter is the object which I will explain you, and then I'm running the loop here. So first, this will run first time. So this will print 1. This will run second time. This will print 2 here. So we have 1, 2 only. 1, 2. Not 3, 4, 5, 6. Then I can run again some statement, nest statement. Okay. This is for 3. This is for 4. This is for 5. Okay. This is for 5. And this is for 6. Okay, now we are running numbers 1 by 1. Okay, 1, 2, 3, 4, 5, 6. Now these numbers are not storing in a memory altogether. It is running 1 by 1. It's storing one at a time and then out running it. Then again, Python is storing number second and then printing it. Then Python is storing number 3 and then printing it. So one number at a time. So here you can notice, here we are using iter here. Iter is a object here. Now what is iter here? See, we have 3 concepts. We have iterable, iter, iteration. What is iterable here? An object that can be iterated over. For example, here, this is my iterable. Okay, this is my iterable because I have made this integer into a string. So this is my iterable here. Like any object which we can iterate on. So we can iterate on the list, we can iterate on the string. What is iterating? Like we can run a loop on top of the data types. Those are known as iterable, which is list is a iterable, string is a iterable, and so on. Okay, it must implement the iter method, which runs an iterator. And what is an iterator here? An object that represents a stream of data and knows how to return the next element when requested. It must implement the iter method or next method, which means iterator is the object which is used for the iteration. Okay, for example, this one, this nest method, this is a iterator here. This is the iterator. Why? Because it is used for running the iterations. And then last with this iteration, the process of accessing each item in a collection one by one, typically done using a loop. Iteration is a process. So what kind of process are we following? This is all iteration here. So we have 3 concepts in the generator only, which is iterable. Iterable is the object, like iterable, we can say, which we are iterating on. For example, we can iterate on the for loop, sorry, we can iterate on the strings, we can iterate on the list, tuples, dictionaries. Those are my iterable objects, which I can iterate on. Iterator is the object which is used for the iteration, and then with iteration, which is a process of printing one element at a time, which is this one. We are printing 1, 2, 3, 4, 5, 6. This is the process of iteration. So we have these 3 concepts, iterable, iterator, and iteration.
Mhm.
Is it clear?
Yes, teacher.
For example, let's take a very simple example for now. This is a complex one. Let's say we have a tuple here, my tuple. And this will take 3 elements, apple, orange, cherry. Now we have 2 options. First, we can run loop on top of it. But if I run the loop, the Python will first store all my elements in a memory and then run it. What I want is, I don't want it to fill my memory. I want one element at a time. So I will create an iterator here, my iterator, equal. I will call an iterator here, which is iter is a function here, which will take iterable. What is iterable here? My tuple. My tuple is a iterable here. So my tuple is a iterable because we are running iteration on top of my tuple, which is a iterable here. Iter is my iterator here, this iter. Why? Because I am using this iter for running my iteration, for doing my iteration process. Okay, now I can print nest here. Nest, and I can run my it. So this is another way. If I run this one nest it, you will notice apple only, just apple. Okay, then I just wanted to run orange and cherry as well, so I will run this. orange, and this cherry. So now you can notice orange as well and cherry as well. And this process is known as iteration, where we are iterating one element at a time. That is known as iteration. Okay. So this is an example of iterator, iterable, and iteration. So
Mhm.
let's take one more example of the iteration. So let's say we have our list here, my underscore list. Inside list, we are creating a 1, 2, 3, 4, 5, 6, 6 numbers element, like 6 number list. Here I'm creating the iterator here, iterator equal. I just wanted to iter on top of my list. My list is a iterable. Okay, it is a iterable because I'm running loop on top of my list only. So this is my iterable. This is my iterator here, this line, and then I will do the iteration process. So I will run a loop here, while true here. So we will use a try block. Try. Now we will get the next element. Okay, we will get the next element. What is the next element here? Item. Item equal nest of which one? Iterator. Nest of iterator. And then we are printing the item. Print item. And if the item finishes, like after 6, if we don't have any item, then we will run an except block. That and this is except block will take a error which is stop iteration, and then we will break the. This is my loop here. Okay, now you can notice if I run this one, you will notice 1, 2, 3, 4, 5, 6, right? Because now you can see we have no error here. Why? Because I'm using a while loop first, and the condition is true until the loop is complete. I'm sorry, there's a connection loss. Am I audible?
Okay.
Yeah. So here we are trying. Okay, we have this get the next element. So with this iterator here, okay. So here this condition will always remain true until my all the elements will finish. So here we are printing element one by one. Okay, basically I'm running all together. You can see we are running all together, but these are not running all together in the background. These are running one by one. First number is storing in the memory. Okay, and then printing it one, and then Python is storing second number in the memory, and then running it second, then third number in the memory, and then running it. So storing one number at a time in the memory. And then if the elements are completed, then we can stop the iteration and then we can break the loop. That is how it is working. So this is another example of iteration. Iteration, iterable, and iterator. Okay, so now let's see one more example. Let's say I have a class. Class is my number. Okay, which will which will take which will here we are running initializer as a self here. Okay, then here I'm using self dot a equal 1, and then we are returning the a here. Sorry, self here. Okay, now let's see. I'm creating another function def underscore underscore next here underscore underscore. Here I'm using again self here, and x equals self dot a, and then here we are incrementing the value of a and then return the x. Return x here. So I have a class. Inside my class, I have two functions. First initializer and the next function. Okay. Now let's say I'm just creating. Let's say I am creating a class, my object, let's say. In this object, I'm storing my numbers as a class. And then now I'm creating another iter here, another object here, iter, which will take iter as my object. Okay, now you will see, for now, nothing will happen. Okay, we have just not none, not my number. Okay, so what we can do, now we have to run the loop. We can use print next my iter. So this will run number one. Okay, number one, you can see. Error here, my name. So, cost. Everything is okay. My number, and then we are using my iter as my class. There's some error here. What is that? Underscore should return none, not my name.
Mm.
The number is not happy. Ah,
Mm.
so what we were trying to do is we wanted to clone the iterator here. Okay, we are creating our own iterator and like iterable. So here I am having this issue. I will see it and I will tell you later. Okay, I will fix it and I will
Mhm.
share you the code. Okay, for now.
Thank you, teacher. Okay.
So what we are trying to do, I just try to do. I'm just creating my iterator and the iterable and iteration in this class. And this class is throwing the error. So I will fix it and I will upload the errors. Okay, so this is the concept of iteration, iterator, and iterable, and generators. Generator will run one by one. Okay, with the help of yield. When you see yield inside a function, then that is a generator. And we have
Mhm.
to access the generator elements by running nest here. Nest is a like a magic method here. Without nest, you cannot access the generator here. So whenever you're using nest, you're calling the generator elements one by one. One, two, three, line by line. Okay. So here you can notice we have the same examples. Okay. So we are taking this example of my numbers. Let me copy this one. This is running my function. It's okay. So here you can see the same function. Here we have this number as a class, and then here we have this two functions inside my numbers. First is iterate, and nest here. Sorry, I have used iter here, not init. That was the issue. I was using initializer here. But here comes iter here. Okay, that is the issue. So now I'm using iter, and this will take no parameter for now. And here inside iter, I have created a variable, which is 1. 1 is a variable here. Okay, then in the nest initializer, I'm using nest here. Nest is again a magic method. And this nest will keep on incrementing the value. Okay, so the more we run, the more it will increment the value. Okay, but it is not an infinite loop. Infinite loop is like when the loop is not ending. But here we can run as many as nest statement as we want. Okay, I can run as many statement as I want. But this will never ending. But it is not a infinite loop. Infinite loop is like when the loop is not ending intentionally. But here we are doing this intentionally. Like here we can run as many statement as we want and we can run the number. The more statement you print here, the more increment it will take. So now we are storing x, we are storing a in the x, and then we are incrementing the value of 1, sorry, a, and then we are returning the x. Then I have this object here, my class, which will take my numbers as a like a class here. My class is a reference variable. Remember when I said it is not object, it is a reference variable. Then
Mm-hmm.
my iter is another object. Okay, only is a kind of a reference variable, which will is iterating over my class, which is iterating over my class. So now my class is a iterable here. Iter is a iterator, and here we are running one by one. So if I run, you will notice many numbers, 1 to 10, but these are not ending. If I run this again, you will notice another number. If I print here, then you will see some more numbers. So they're like never ending, 40 number. So what the
Mm-hmm.
Python is doing, Python is storing one number at a time and then printing it. Then second number at a time and then printing it. Third number, fourth number, fifth number, one by one. So it is not filling up my memory. So that is a benefit of using generators, iterators, iterable, and iterations. Okay. Is it clear?
Yes, teacher.
Then we have another variation of the generators, which is known as coroutines. Okay. So now we can discuss. Now, what are coroutines? See, a coroutine is a special type of function that can pause its execution and return control to the caller and then resume execution later from where it is left off. That is a main benefit of coroutines. For example, if I run a for loop for I in range, let's say 1 to 10, and if I print here I, you will notice 1 to 9 all together. 1 to 9. If I run this again, you will notice 1 to 9 again. If I run again, you will notice 1 to 9 again. So each time I am running my loop is starting again, ending again, starting again, ending again. So it is like starting from the starting. 1 to 9 again, then I run the again, then I run the loop again 1 to 10. Then I run again 1 to 10. So that is for loop, simple for loop. So now what is the benefit of coroutine over for loop? Coroutine is like, let's say I'm running numbers 1, 2, 3, 4, 5. Now let's say I pause on number second. Let's say I just don't want it to print number 3, 4, 5 for now. So coroutine will pause up to number 2 and remember where they have paused. Okay, remember where they have stopped. And when I again run the coroutine, they will start from number 3, not from the starting. They will start from the number 3. That is the benefit of using coroutine. Okay, and here you can notice the definition says that can pause its execution and return control to the caller and then resume the execution later from where it is left off. So if I'm running 1, 2, 3, 4, 5, and let's say I stop at number 2, I don't want number 3, 4, 5 for now. I want later. So when I later run the program, it will resume from 3 only, not from the starting. That is a benefit of using coroutines. Coroutines are useful for cooperative multitasking. If you are doing any multitasking, let's say you are running two programs. You want one program to run for like in the stop in the half and run after half. For example, let's say you are running two programs, one program and two program. First program you want to run half one time, half second time. So the first you are running the first program half, and then you are running the second program, and then you are running the first program, the remaining program in half. So that is like you can do a multitasking here in the with the help of coroutines. Okay. Where task voluntarily yield control to allow other tasks to run, and from asynchronous programming, where task can wait for external events without blocking the entire program. So let's say there's a program, and let's say I am creating a any program, and let's say the program says the program is running. Okay. And at this line, the program says enter, press enter, then I will run the next line. Okay, like we have 4 lines, 5 lines, let's say. At this line, I says to the user that press enter, then I will run the rest of the code. So here we are stopping here. We are stopping here and waiting for the user to print something. Sorry, to enter something, to press enter key. Then I will resume the rest of the program. So we can just block the flow of the program, and then we can resume it later from there only where we left off without blocking the other programs. Okay. For example, let's say we have function here which will print hello world and hello universe. Two programs, hello world and hello universe. After hello world, I just take a pause, my program take a pause, and here my program says press enter. So this program is on hold here. Okay, this program is on hold. Okay, so hello universe is yet to print. And I have second function also, and then second function is running as it is without stopping. Okay, so when I press enter, the hello universe will be printed from here only. It is not like starting again, it is printing from here only. So what I mean is I can hold any program and run the entire piece of code of Python, and then I can resume it from where I left off. That is a like a function of coroutines. Okay, like the
Mm-hmm.
purpose of coroutine. Is it clear?
Yes, teacher.
So let's take an example for the coroutine. Let's say I have a simple counter here. Okay, simple counter as a function here, which will count. Here we have this variable count, which is a 0. Here we are running a while loop, while true x equal. Here we are using yield function. Okay, yield count, which means we are running count one by one, 1, 2, 3, 4, like this, not all together. Okay, and here you can notice we will pause here and wait for a value to be set.
Mm-hmm.
Then here we can use if x is null. If we have no value in the x, then this will count. We are incrementing that count value. And then else, if we have some value, then we are returning count equal x. Okay, there. Here we have a counter which we are initializing. I'm calling my simple counter as a function. Okay, then I can print here next count. So first you can see we have a function. In the function, we have a variable count, which is a 0 here. For now, I'm just running my next counter here. What is the value of counter here? See,
0.
counter is this function in 0. We're calling this count here. So this will return 0 here. 0. Okay, but now I run it again. But for now, I just print counter, and now I will send a value here. Okay, I will send a value. Let's say value number 12. So which value will run? Value number 0 and 12. If I run again, see, if I run the counter again without providing any value, so this will return 13. Okay, you can see 13. But if I send any other value again here, let's say value number 5. So this will return 0, 12, 13, and 5. You can notice we are stopping from where we are just resuming from where we stop. So how the program is working? The program is very simple. It is saying that we have a variable counter. Yeah, we have a variable counter here, which is count here, which is 0 here, and we are running a loop. And this loop will keep on running. Okay, this is a forever loop, but it is not an infinite loop. Because how many times I have to run my loop, that is in my hand. That is in my hand. So I'm running the yield statement and count one by one. I'm printing one by one. So I'm saying if user is passing nothing as a value, here we are not passing any value, here we are not passing any value. If we are not passing any value, then increment the counter by one. And if we are passing any value, then print that value. Okay, which means if I am passing 12, then print 12. If I am not passing anything, then resume from the 12 only and increment by 1, which is 12 plus 1, 13. Same as if I run this line again, you can notice I have print 5. After 5, I have print counter again, next counter. So this will resume from 5 only and print 6 here. So 0, 12, 13, 5 and 6. If I'm not providing any value, so this will increment by 1 from the previous state. Okay, and if I providing any value, so this will print that value. That is a function. So what is important is this, we are pausing here only on 5. And then if I run again my counter, which is my class again, sorry, my function again, I am resuming from the previous value only. That is why I'm incrementing 5 plus 1, 6. Let's see if I have another number here. Let's say number 8 here. So now it will print number 8. Okay, number 8. So now how it is a proof that I am resuming from there? So if I print next again, so this will increment by 1. So which number is increment by 1? Number 8. Because we are resuming from a number 8 only. So now we have number 9. Okay, number 9.
Mm.
So we are just resuming from here only, from 8 only. So this is like a coroutine example. We are just incrementing by 1. Okay, and we are resuming where we left. Is it clear, this example?
Yes, teacher. That's cool.
Okay. Now, then we can move. Now the advanced concepts are over of OOPS, okay, of the inheritance, polymorphism, abstractions, and this encapsulation, private method, private variables, public variables, etc. And then we have completed the decorators, generators, coroutines, and iterators. Okay, now we will move to a project. We will create a CLI project where we will use the concept of OOPS. Okay, now first I will tell you how the project will look like so that we can create it. So I will create a new file for now for my project. It is a CLI based project. Okay. The project will look like we are creating a library management system. A library management system where I have some parameters. So what a user can do in a library management system, a user can add a book. Okay. And this book will take 3 parameters. Okay, book will take 3 parameters: book name, author name, and publication date of the book. Then second option, we will providing the user to view all the books in the library, view all the books in the library. Third option is we can give an option to search for a book. Why? Its title. So this will take title as a parameter for searching. And fourth, we can quit. This is my very simple project. I will create a library management system and I will provide a menu like this to the user. My user can select any of the option from 1, 2, 3, 4. And then if a user click on first option, add a book. So the program will ask to print a book name, apply a book name, author name, and publication date. And the book will be added. Then we have the second here. Second option is a user can view all the books. So a list of books will be printed on the screen. Then the user can also search for the book by its title, and then he or she can quit also. This is my project. Is it clear, the idea of the project? Any questions from this idea?
No, teacher, that's good. Let's.
How we can
Uh,
approach this problem?
mhm.
Any answers? Like how we can start by creating this project.
Yeah, we need to make a list. List the book, list of books, and then appeal the books. Wait.
Okay, so this program is not easy. So let's create it first. Okay.
Yes,
So
yes, teacher,
first,
please.
so first I will create a class for the book. Okay, for the book, which will initialize, which will initialize here. Okay, we are initializing, and this will take three parameters. First parameter is book title. Second parameter is book author. And third parameter is date, publication date, which is publication date. So this, or I can write here short name year. Okay, like the year when the book published. Then I will use self dot title equal title here. Then self dot author here. Self dot year. And then we are printing here. We have to print here underscore str. Str is again a magic method, and this is for printing something. Now I am printing the book name, the title, the author, and the year. So here I can return. Okay, I am using a F string here. Here I am using first the self dot title. Okay. And here I am using Y. Here I can use self dot author. I'm calling author here. Okay. And here I can call in self dot year. Okay. This is my first class. So let me show you. Let me run it. Okay. So oops underscore project underscore library management system. And I'm saving dot py. Yeah. So I'm just running it. Then I will show you what is happening here. I'm creating an object for my book class, which will take three parameters: title, author, and year. Let's say the book title is The Power of Now book. Okay, book name here. And then we have the author here. Let's say author is Eckhart Tolle, and year is 2000, I think 12. I don't know. Okay, I have this one. Now I can print the object, not object actually. Let's say object here. So now you can notice the power of now by Eckhart Tolle 2012. This is what this line is printing here, because it is taking three parameters: title, author, and year. And here with this title, author, and year. Okay, this is my book here, which means this is a parameter. This is a class where I can add a book, where a user can add a book. So this is for adding a book in the library. Okay, for now we don't need this one. The second class I will create for the library class. This will take three parameters, three classes, three methods. Here you first with this init, and here you get the self here, which will run self dot books. Okay, here I have a empty list here. So whenever I will keep on adding books, I will add here. Okay, when a user will adding books, he or she will add here. Then def, we will create a function, means a method add underscore books. When we are adding a book, this will take self and book as a parameter. And here I am calling self dot books dot append. So whatever book I am adding, I am appending in the list of the self books. All the books will be added here in the self dot books. And then I can print here that I can put here book self dot book name, which is book dot title. So with book dot title added to the library. This is my add books feature here. Then I have second method here, in my library def view books, where I can see all my books. Okay, which will take self as a parameter. We are just printing all the books. So we can use in if not self dot books. Okay, if the books is empty, if this list is empty, okay, then what we can do, we can print here no books in the library. Okay, no books in the library. Else, we can print, we can run a loop for book in self dot books, and then we can print book here, which means if the books are in the library, means in this particular list, because in this list, I have the list of all the of all the books added by the user. So whenever the user will add books, it will add here, append here, because we are appending here. And if this list is empty, if this list is empty, then no books in the library. And if the list is not empty, then we are looping over this list. Like we are printing all the books in the library. Okay. Then we have search option. Okay, for searching the books. So we can use def search method, search for the books. So this will take self and a title for searching. Okay, now here we can use found underscore books. So here we can use a loop here, a very simple loop. That is first for book in self dot books. So we are looping again on this list, particular list. Okay, if we are looping, then we are checking if title dot lower. Okay, I will tell you why we are using lower in books. In book dot title dot lower. Then simply print that book. Here I'm using a list comprehension. What is list comprehension? When I'm using a for loop in the same line. In the same line. Okay. Then here we can use if not found books. If we don't have any books in the found books, in found book list here, then we can say print book not found. Okay. Else we can print, we can loop over the found book. So for book in found book, found book is a list. And then here we can use print book. This is my search option here. Okay. So see, first I will create a program, then I will tell you. This is my simple class here. Now outside of this class, I am creating a menu here. We want a menu like this one. We want the user to see these options, and we have to create a menu. So we can create a simple menu, show underscore menu. Okay, which will take print statements, print. First add a book. And before that, we can print here, welcome to the library management system. This is my title of my library management system. First, we can add a book. Second, we can view all books. Third, we can search a book, search for a book by its title. And fourth, we can exit. This is my menu here. Simple. Okay, this is my function which contains just a menu. Then I can create a main function. A main function. Main. This is the function where we will do all the operations. Okay, like run all these functions. How? See, my main function takes library. Here I'm creating an object. Okay, I'm creating an object of this library class. Here, library here. And my class is capital library. This one. Okay. Now here I'm just running a for loop. Sorry, a while loop, and that loop is forever. Until the user press the exit number, like number 4 here. So here I can use while true. First, I will going to show the menu to the user. This menu will always print whenever we are running the class. sorry, the show menu, this main function. Then here I can create a option here for choice. If our user wanted to choice, then here I can use input. Input, enter your choice. Means a user can apply 1, 2, 3, 4 as a choice here. Okay. So here we are providing a user to a choice, to input a choice. Then here I'm using if. If choice is equal to 1. If choice is 1, like if first choice is add a book, then we will call this function, this particular function book here. Okay. Sorry, this particular method, add books here. So how? See, first we will choose 1. If a person choose 1, then we will ask for the title, enter the title of the book. Then we will ask, enter the author of the book. And then we will ask, enter the publication date, enter the year of the book published. These are the 3 input statement. And if the user apply, then we will printing this inside book equal. Now we are calling book as a, see, we are calling this particular function, this particular class, this class. This class takes 3 parameters, title, author, and year. This is what we are giving here, title, author, year. Okay, and then I am just adding, I'm calling my library with object, and here I'm adding book as book here. Simple. See, if the user choose 1 as a parameter, what is 1 here? Add a book. Then I'm asking the title, the author, and the year from the user. And then I'm creating an object for my first class. What is my first class? Book. This will take a book, the title of the book, the author of the book, and year of the book, and print it. Okay, automatically. So here we are giving the parameters of title, author, and year. And these title, author, and year will be printed by the user. And then I'm calling my library object here, which is this object here. And then I'm adding a book. And what is the book? Which the user will apply inside this book. Because you notice we have a add books as a method here, which will take book as a parameter. So we have to provide book as a argument here. Okay, inside this book, we have author, title, and publication date. And when we have this one, we will append the book in the cell.books. Cell.books is my list, where I will have the list of all my books. And then I'm printing this line, which is your book title will be added to the library. This is the add books feature. Very, very simple. Okay. Then I will create a second choice here. Elif. If choice is equal to 2, these number are strings because here we are taking input as a string. Sorry, here I'm taking input as a string, not as a number. So that is why I'm adding a string as a number here. Okay, if choice is 2, which is for view all the books. So first we will print a new line first. Okay. And here we can print list of all the books. I think here I can also use a new line character. Okay. Yeah. This is for the new line. We have this heading here, which is list all the books. And here we are using a library and view books. Okay. Here I'm calling library as my object here. Inside library class, we have this view books. Inside this view books, I'm first checking if this particular list is empty, then print this line, no books in the library. And if this particular list is not empty, then run a loop on the list and print all the books one by one. Okay, that is what I'm running in the view loops. Then, if the choice is library or view loops. Okay. Now, if elif, if the choice is third choice, then here I will ask for the title. Third choice is what? Search for a book by its title. So I want a title from the user. So I will print input. So here I can use enter the book title you are or just to search. Simple. to search. And we will check. Then here we will print a line. Okay, first a new line here. So search, this is for the search results. Okay, if a user search, so here we have the search result, and the search result call the library dot search books function, which will take title as a parameter. Easy. So now if the user chooses third, search for the book, then we will first ask, enter the book title you wanted to search, and then we are printing this statement, search result, and then we are calling this function inside a library object, which is search books, this function. This will search
Mhm.
for a book, and this will take a title here as a parameter. And here we have this argument title, and this title will give by the user here. And here this function is saying here we have the list here. Okay, here we have the list here. Let's say we have two books. Let's say the two books is Power of Now and Power of Python, and user is searching with the power. Okay, user is searching with the keyword title power. In that case, we have two books matching Power of Now and Power of Python, right? So that is why I'm creating a list here, found book. If we have more than one book, then we are putting this in the list. This function, this loop says for book in cell books. First, we are iterating over the cell books. What is cell books here? Cell books is another list here, this one. Inside this, I have a list of all the books. So we are iterating over the cell books. Then we are checking if the title dot lower. What is title here? Let's say the user print title here. Title is this one. Let's say user print power. Now you can see this power is in uppercase and this other is lowercase. So this will not match. For example, the book title is power. This title. Okay, this title. And user is printing power. Now this power and this power are different. So that is why we are just converting the title in the lowercase so that we can match. And we are checking if the title dot lower, we are converting the title in the lowercase in book dot title dot lower. And we are also converting the title of the books in the lowercase. For example, the user apply the book name is The Power of Now. Let's say the user put this name. Now this is not in uppercase, not proper in the lowercase. So what I'm doing, I'm just converting this entire Power of Now title in the lowercase as well. Here. Okay, lowercase. So that I can match the lowercase together because Python is a case sensitive. We cannot, Python cannot understand uppercase or lowercase differently. So Python is like Python can understand only lowercase or uppercase. It cannot understand that if uppercase P and lowercase p are equal or not. It cannot understand. So that is why we are converting the title in the lowercase and the title inside the book in the lowercase. Okay, which is in the list. And then we are checking if the book in the cell dot books, then print a book. So if we have more than two books, then we are just closing inside a list. So here we are creating a list. Okay, we are creating a list here. So if we have let's say we have one book, second book, third book. So if we have same three books containing the power keyword, then we are printing it inside a list. We are putting this inside a list so that we can print the list here. So we can say if not found book, if this list is empty, if this list is empty, then book not found. If the list is not empty, then we are looping over the list. Okay, like we are printing one by one book title from this font. Okay, because it is itself is a book. Sorry, itself is a list here. So if we have more than two books, then we are looping in this found book. Okay, so we have this last feature which is choice here. Then last choice here we have else, or we can just put elif. Let's say elif if choice is equal to 4 for the exit. Then we can exit the loop. Okay, so we can say thank you for using the library management system, and then we can use break here. Break for breaking the loop. Because this condition will always remain true. This condition until we break the file loop. So that is what I am breaking here. If the user print 4, then we are breaking the loop. Okay, else if there's any error, if user print any number apart from 1, 2, 3, 4, then we can print here Please enter the valid option. Okay. So this we are printing here. Okay, this is my library management system. Now I can run it. How we can run? We can simply use if underscore underscore name underscore underscore is equal to underscore underscore name underscore underscore. Then we have to use double equal sign. Then we can call the main function. So actually we are calling the main function. Okay, we are calling the main function. What is main function here? This one. So we are here checking a condition. If name is equal to main, if this name is equal to this function, then call the main function. So Python will call actually the main function, this one. Inside main function, we have created an object for the library class, which is this library class. And then we have this loop. And this loop will forever run until we press the 4 number. Okay, break it. Okay, if the number, if the, and when we run the loop, we are showing a menu. Show menu is always there. So we will show this menu. We are calling this show menu here. And then here we have this choice. Input, enter your choice. So we are asking for the choice. So if the user print 1, then we are calling this add books. If user print 2, then view books. And third, search books. And at last 4, thank you for using the library management system. Okay, so let me show you the code, how we can run it. I'm not running in my Python VS Code. I will run in the online compilation. So I'm searching for the Python online compiler. Not this one. This one. I'm running here. So you can run in your VS Code. No worry, but I'm running here so that I can run it again and again. So this is my function. Now I can run it. So you can see, welcome to the library management system. So we have 4 options. And here you can see this menu is printing first, this menu. And the code is still running because here we are using a while. This code is still running. So let's say first, I want to add a book. So it is asking enter a title, which is this one. So now I can add a title. Let's say the power of now. Okay, the author name, let's say author name is Eckhart. Let's say year of publication is 2010. So now you can see the power of now book, the power of now added to the library. Then it is again asking for the menu. Okay, so you can see after this particular function is over, then we are again calling the menu here. Okay, show menu. This one, because we are running a while loop. This will keep on running until you press the 4 button. Okay, like this 4 here. Let's say if I press 6 here. So it is saying, please enter the valid option. Now I say that, okay, I just wanted to see all the books. So I will click on second, view all the books. Now you can notice list of all the books, which is, we have one book only, which is The Power of Now by Eckhart Tolle 2010. This line is printing from here, from this line number 1, this line. Okay, now let's say I just wanted to search for a book, 3 here. Okay, you can see enter the book title to search. Let's say I just wanted to search a book title, which is starting from power, or just contain power as a title here. So you can see search results, The Power of Now. Why? Eckhart Tolle, this one. So we have the search result. Let's say I just wanted to add another book here, 1. Now let's say, please run the code again. Okay, the session is ended. How is it possible? How the session is ended? Search for the books, print books. Let me run again. Let's say we are searching, we are adding a book. Book name is again Power of Now. Name Tolle 2010. Now let's say I'm just searching for a book, Power here. Yeah. Then you can see the Power of Now has search results. Then it is again asking that what kind of operation you wanted to perform. Let's say I just wanted to add another book here, 1. So again enter, let's say Power of Python. And author name is, let's say, XYZ. Publication is 2011. Now you can see book Power of Python added to library. If I click on second, now you will see 2 books here, The Power of Now and The Power of Python. Now, if I search for power, simple power, then you will see list of two files. Search results. Two books here, Power of Now and Power of Python. And if I press exit 4, so this will exit from the code. Okay, thank you for using the library management system. Okay, so this is what it is running. If I simply click on number second, view all books, second year. So now you can see no books in the library because we have not added any books. If I click on third to search any, let's say XYZ, so you can see book not found from the search because we don't have any book. If I add a book here, let's say again, let's say book name is ABC, author name is XYZ, let's say for now, and 2010. Okay, you can see book added. Now let's say I'm searching for a book with the name Power. So you can see no book found. Okay, because we have one book only, which is book name is one book only, which is book name is XYZ. Sorry, ABC. Okay, that is why when I search for Power, it says no book found for the name Power. Okay, is it clear? The program?
That's a lot, teacher, huh? Yeah, but how about the exit, teacher? I didn't see the choice exit.
This one, fourth. If we exit, then here we have this program, ELF, choice 4. Then we are saying that thank you for using the library management system and break. We are breaking
Okay.
the code.
Oh,
So I will share this code. You can run it one time. Okay, you can
yes.
create it by your own. You can add some more features like let's say we can say if you wanted to, if the user is trying to add any book which is already there, then you can say book already exists. So you can add another features like this. Okay, like you can think of a library management system online and then you can clone that particular features in
Yeah.
your class.
Okay.
Okay.
That's good.
For now, is it clear? This code?
Yes. Yes, teacher.
Okay. So I will share this code and one time you can run it. And same as with
Yes.
this project, you can create another project. Let's say you can create a student management system or employee management system where you can print the name of the employee code, and so on. So you have many ideas. You can start creating the
Oh,
projects. If you create projects, you will see you will practice all the concept which we have studied. Okay.
correct.
Okay.
Yes.
Later on we will when we will study the database, so in that I will show you how you can create a login system where a user can
Yes.
apply the username and password. Okay, a
Mm-hmm.
login system in the database section. Okay, for
Yeah.
now we don't have any login management here for now,
Mm-hmm.
but you can create easily. You can ask for the username and password and you can match if the username is right or not in the list, and then with the password. So we have many possibilities here in this project. Okay,
Mm-hmm.
so any questions up to here?
No, teacher, thank you. That's a lot, but I need to practice again.
Yeah, you have to practice, and oops are very important for the Python.
Mm-hmm.
It is like a fundamental base for the Python. Okay,
Yes.
so you have to practice. The more you practice, the more you will uh, capture these
Understand
concepts.
each, yeah, understand each function, right, teacher?
And I will share some questions from the oops so that you can try it by
Mhm.
yourself. Okay.
Yes, teacher.
And tomorrow we will discuss the GUI applications, like how we can create graphical user interface applications. Okay, like which have
Grapple.
a colors, buttons. Okay, for example, we have this VS Code. This is a graphical user application. Like we have buttons here, we have colors here,
Mm-hmm.
and etc. Same as we will create with the help of Python using a
Mm-hmm.
printer library. Okay, tomorrow we will see that.
Yeah, hey, thank you, teacher.
Any
Can
other
you send?
questions?
No, teacher, just send the video and the notes, and then I will
Yeah,
practice.
yeah, I will share, and you can practice why today. And if you have any doubt, you can ask me tomorrow. Okay, or
Yes,
any other
teacher.
day.
Yes, teacher. Thank you very much, teacher.
Thank you. Take care.
Yeah, you too. Bye.